Hey guys, so you're moving on to chapter 10 today. We're going to deal with area this chapter, and today you're going to talk about area of parallelograms, triangles, as well as trapezoid, kites, and rhombuses. Your sub should have given you a template for your notes today to just make taking notes a little bit easier. Please make sure you're watching and listening to this video, so it's just like if I were teaching right in front of you. So to get us started, we have area of a parallelogram. So the area formula is base times height. So your B stands for base and your H stands for height. So if you wanted to write that in, you could certainly do so. So we have base and then we have height. Okay. And so these are what your pictures can kind of look like. It can be like a rectangle or a square where your base and your height are shown right there. But if we were to have like more of an actual parallelogram, the height is not going to be one of the sides over here. The height is actually like an altitude. So from one base to the other base, where it's a 90-degree angle, that line is meeting this base at a 90-degree angle. That's actually going to be your height. So you need to be careful with what you're noticing as your height when it comes to parallelograms like this. So this is going to go under your number 1 where it says diagram 1 and diagram 2 on your notes. So you might have to pause the video in order to actually get this down. So our first examples of each are going to be these parallelograms here. So I'm going to go ahead and just draw a line in between these examples so they don't go ahead and get mushed up. So in our example on the left hand side, our 12 right here is going to be our base because that's the base of the parallelogram. And this 8 over here is going to be the height because it is going from one base to the other at a 90-degree angle. So that's our perpendicular line, which means it's also our altitude, which means it's going to be our height. So again, our formula for this is area equals base times height. So if I were to write my formula again, because repetition helps me remember things, my base is going to be 8, my height is going to be 12, and so then my actual area is going to be 96. So make sure you're getting that down. Now in this, in our example number 2, we have a right triangle right there, and we are missing one of our legs, which happens to be the actual height of this parallelogram. So in order to do that, we can pull in from what we learned in chapter 8 about the Pythagorean theorem. Because this is a right triangle, we have two sides of the right triangle, so then we can find the third. So first we're going to use our Pythagorean theorem. So 12 squared plus x squared equals 20 squared to figure out what that is. So that gives us 144 plus x squared, and that's going to go ahead and equal to 256. Actually, that's a lie. 20 squared, do not know that off the top of my head. I believe that's 400, but let's make sure. Yep, that's going to be 400. So let me go ahead and erase that. All right, and then when I go ahead and subtract the 144 over, I get x equals 256. So when we take the square root of both sides, the x is going to equal 16. So our x is equal to 16, which is going to also be our height. And then the 24 right here is going to be our base. So even though it's on the top, that can still be our base. So then our actual area formula is going to be area equals base times height, which is equal to 16 times 24. And that is going to equal 384 as our area for this example. So make sure you get these examples down in your notes on the template that I gave you. Again, you might have to pause the video. The next one we're going to talk about is how to find the area of the shaded region in this rectangle. So in order to find the shaded region, that's going to be this piece right here. On your paper, it is gray, but what you need to do is find the area of the small rectangle, find the area of this big rectangle here, and then subtract the two. So the area here is going to be 4 times 12, which is 48. And then the area for the bigger triangle is going to be 10 times 12, which is going to go ahead and give, oh, I'm sorry, not 10 times 12. I looked at the wrong number. It's going to be 10 times 18, which is going to give us 180. So the area that we are looking for is 180 minus 48, and that is going to give us 132, and that's just of the shaded region. So here we have the area of a triangle, so it's going to be 1/2 times base times your height. So again, if you need to write it in, you can say that is your base, and the H is going to stand for height. And again, you have these two different diagrams right here. So your height comes from a vertex, and it's an altitude. So if you remember what an altitude is, it comes from your vertex, hits the base at a 90-degree angle. So it's got to be important that's a 90-degree angle. So over here is not going to be your height, just like it was with a parallelogram. Sometimes your height is going to be outside of your triangle, like it is in diagram 2, and that's okay. That's going to be our height. However, your base is still just going to cover from here to here. That's what your base is going to be. It does not extend to the dotted line out here. No, no, no. Only the bottom of your actual triangle. So some examples here. So the 6 down here is going to be our base, and the 3 is going to be our height. So again, our area is going to be 1/2 times base times height. So my area over here is going to be 1/2 3 times 6. So that's going to be 1/2 of 18, which gives us 9. Now over here in the right triangle, we have to figure out our base and our height as well. So our base is still going to be 6 here. Now we have a 5 and then we have a 3. However, the 5 is a slanted side and the 3 is a straight up and down height. So 3 is actually going to be our height. So the 5 is just extra information that we don't even need. So because we have the same setup as our previous triangle, 1/2 times base and our height, we are still going to get 9 as our answer. And I did just realize that even though it's 1/2 times base times height, I did height times base on both of these, and that's perfectly fine. If you did 6 and then 3 and 6 and then 3, you're going to still get the same answer because 6 times 3 is 18, and then times 1/2 is still going to be 9. So the order that you put the base and the height does not matter. All right, now we are going to go ahead and move on to trapezoids, rhombuses, and kites, and that should be on the back of your paper. So again, you're going to move along to the back side of your paper to where it says trapezoids, and this is lesson 10-2. So first thing here is area of a trapezoid. So I know this looks like a lot, but it's really not that bad. This is all being multiplied except what is inside the parentheses here. So we have 1/2 times the quantity base 1 plus base 2 and your height. So remember, your bases are your two sides that are parallel to each other. So this side right here is going to be parallel to that side right there. So the two sides that are parallel are your bases. And again, it doesn't matter which base comes first as long as it's the correct things. The height is the same thing as in the triangle. It has to be that perpendicular line that hits the bases. So it goes from one base to the other, and that's going to be your height. This slanted side is not your height, so please make sure you're paying attention to your actual height of your trapezoid. So we have our examples here. So you can label the top as your base 1 if you want to, and the bottom as your base 2. You could reverse it if you want, does not matter. Your height right here, we can see that this line is creating a 90 degrees with the base down here, so that is our actual height. So we just plug it into our formula. So we have the area 1/2, our base 1, which is 9 plus 15, base 2, times our height. When we go ahead and put that all in, we get 72 for our area there. Now in our example number 2, I'm going to go ahead and move this up a little bit. But in our example number 2, we still have our two bases in this. So we have that 12 is going to be our base, and then so is 2. So 12 can be my base 1, 2 can be my base 2, or again, vice versa. So we can do area equals 1/2. We have 12 plus 2 times 7, because 7 is going to be our height, because it is going from one base to the other at a 90-degree angle, because it's meeting this base at a 90-degree angle, so it's perpendicular. When we go ahead and type that all into our calculator, we go ahead and get 49 as our area for the pink trapezoid. So make sure you're getting these examples down. Now, the area of a rhombus or a kite. So I understand that a rhombus is a parallelogram, but with this kind of rhombus, or this kind of parallelogram, we're not given side measurements, we're not given the base, we're not given the height. However, we are given information about the diagonals. So we can actually deal with the diagonals using this formula. So that means that the D in this stands for diagonal. So we're going to add the entire diagonal, get the entire diagonals, and then multiply by each other, and then multiply by 1/2. So if I were to look at this diagonal right here, this could be my diagonal 1, which equals 10, because 5 plus 5 equals 10. And then in this diagonal, I can say that this is my diagonal 2, which is going to be 8, because that's 4 plus 4. So then when I actually go ahead and do my work, my area is going to be 1/2 10 times 8 and that's going to give me 40 for my diagonals there. All right, so I'm going to do the same thing over here. When I have this diagonal, this is my diagonal 1, that can equal 12. And then my other diagonal, this one right here, this diagonal 2 can equal 16, because that's 6 plus 6. So then if I were to do my diagonal formula, or I'm sorry, my area formula for this, it would be 1/2 times 12 times 16. And then that's going to go ahead and give me 72 as my area for that one. So again, please make sure you're getting these down. If you want to get colored pencils to show these different diagonals and you're adding them together, go right ahead. These are going to be our last two examples, but I would actually like for you to try these on your own. So these must be filled out some way, some shape, some form. At least try on these two examples. Ask one of your neighbors for help if you get stuck, but I would like for you to get these two on your own. But I am going to be looking for something there on Friday when I'm checking your notes. So please make sure something on here is filled out. After you're done with all of that, you need to go ahead and get onto this practice. So you are going to go to www.joinmyquiz.com, and then your access code is going to be the 689228. And then you have as many tries as you want until 6 p.m. So please make sure that you are paying attention to this deadline. It is 6 p.m. on the 21st, which is, I believe, on Friday, if I'm not mistaken. Let me double check on that real quick, actually. Yep, so it is due on the 21st. So it's actually going to be due on Friday at 6 p.m. So that way I have RTI on Friday. I believe I have first RTI, so you can come and get help if you need it. And then that way you'll be good to go. And we are moving on to area of polygons on Friday. So make sure you get all these notes. Make sure you get this practice started. The sub is going to be expecting you to at least start this practice before you leave class. I'll see you guys tomorrow.